right, so we're going to do 2 examples today. So go ahead and pause your screen and write down this equation. So this says solve the square root of the quantity of x plus 5 minus 1 equals 3. So I'm going to draw my line down my equal sign. Our goal is to get our radical by itself because we can undo radicals with exponents. So first we need to isolate it. So we have minus 1. So I'm going to add 1 to both sides. Negative 1 plus 1 is 0. So we get the square root of x plus 5 equals 3 plus 1 is 4. So this is a square root. What undoes square roots is exponents. So I'm going to multiply both sides by an exponent of 2. So the square root of x plus 5 is now just x plus 5 equals 4 squared, which is 16. And now we've taken a radical equation and we've turned it into a linear. And we're just going to solve by subtracting 5. So positive 5 minus 5 is 0. And we get x equals 11. And that is our final answer. So here is the next problem. This is not a square root, it's a cube root. I know that because our index here is 3. So pause it and write this down. We have the cube root of x plus 2 equals 4. So just like if this was a square root, our goal is to isolate our cube root. So if we're adding 2, the inverse of addition is subtraction. So I'm going to subtract 2 to both sides. So positive 2 minus 2 is 0. We get the cube root of x equals, 4 minus 2 is 2. So since our index here is 3, we are not going to square both sides. We're actually going to cube both sides. So that gives us x equals, 2 cubed. So that's 2 times 2 times 2. So 8. And that is our answer. And if you need more clarification, remember 2 squared. If I were to, or the square root of 2 squared, well, just think about an exponent. That is the square root of 2 times the square root of 2, which is the square root of 4, which is 2. So whenever you take your exponent and it is your index, whatever your index is on your radical, it is an inverse. So that is why we just get 2. All right, stay safe.